So a guard will basically sit in the middle between different systems that have different classification levels. So if this one server has top secret, and let's say another server has only secret, when it tries to make an access, it has to go through the guard. The guard has rules already set up of what type of information can come through. It may sanitize the data, it may not allow it. And so if it does allow it, then it goes to the top secret system. And usually the top secret system isn't going to be communicating back. The only thing that usually comes back is an acknowledgement of receipt. So you can have a MAC system and have DAC systems and other MAC systems. You don't want them directly to communicate with your server that has such important secrets. And then so that's where the guards come in. They will look at the data, go by their rules, and determine if this type of information can go to that server. So I said that DAC is really what we're most familiar with. We just don't use that terminology usually. That's our Windows, Linux, Unix. Most systems are based on the DAC model. If you as a user can give permission to somebody else, or you can add somebody to a file and say they can read or write or whatever, that's a DAC system. In a MAC system, there's no way that a user has such privileges and rights. A user can't do anything. It's very locked down. And that's because they're holding such sensitive information. Now, one MAC, mandatory access control system, that is out in the corporate world is SE Linux. They took the NSA and Secure Computing took a version of Linux and really locked down the kernel and the whole system. So it works on like classification and clearance mapping. The other types of systems, we don't really know too much about them, and that's how the government likes it.